Hello and welcome to BioRules video lessons. Today we are going to be talking about climate change, and climate change is very intricately related to carbon dioxide and the carbon cycle. So if you remember here the carbon cycle, this is it. We have now a very complex stuff where photosynthesis is used by plants to get carbon dioxide into their body. This may be passed by feeding over here, and respiration will throw it back. No, and if these guys die, they may be decomposed, throwing back that to the atmosphere. But if they're not decomposed, then you can have fossilization over here. And the fossilization, if we get the fossil fuel, we can burn it and release carbon dioxide back to the atmosphere. So I hope you remember this. We saw this in the previous lesson. So let's talk about the carbon history. Once upon a time on Earth, very, very long time ago, 3.5 billion years ago, 1 billion years after Earth was created, carbon dioxide level was very, 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 very high. No, it was higher than 21% that we have today of oxygen. It was very, very, very high. But then life appeared and photosynthesizing organisms appeared, and they start doing photosynthesis. They start getting carbon dioxide into their bodies. So they start kidnapping carbon dioxide from the atmosphere and they put it into their body, doing the process of photosynthesis. CO2 plus water makes organic and oxygen. So carbon dioxide started going down. And interestingly, also these animals start dying, and they didn't have many decompose around. So they start dying and dying and dying and dying. They start getting covered, and they've made fossil fuel. So lots of organisms, they grew, they built, they are around, but also many of them died and got buried. So carbon that was in the atmosphere and the Earth carbon dioxide now was put away into a place that's not accessible for decomposers. So the carbon dioxide went way, way down. So carbon became fossil fuel. There it is. Okay. In the beginning of Earth, when the Earth was showed up over there 4.5 billion years ago, carbon dioxide was very high. But when life appeared, there's something around here. The most accepted time for life is a little bit before 3 billion years ago. So that's life. No? What happened was that photosynthesizing organisms started getting carbon from the atmosphere and putting it down, 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 down. It was above 21%. It went so down that now it is less than 1% carbon dioxide. So why are we talking about carbon dioxide? Because carbon dioxide, in addition to being an important photosynthesizing gas that plants use to do photosynthesis and to make organic energy, it's also a greenhouse gas. So I will explain to you what a greenhouse effect is. So greenhouse effect, it's an analogy to greenhouse, these little glass houses that are used to trap solar energy. So sunlight passes through the glass, it becomes heat. This heat is trapped by the glass and the house gets warm. These houses are made for cold climates to have a decent temperature for people to be growing tropical plants and other stuff like that. And they can even control the temperature by opening a window. If you open a window, you let some heat go away. If you close the window, you keep more heat inside. So it's possible to control that. This is a very good analogy to our planet and the greenhouse gas in our planet. So in our planet, we have an atmosphere. So I'm representing here an atmosphere out of scale. So this is not to scale because the atmosphere is actually very, very, very thin compared to the entire planet. And this atmosphere contains greenhouse gases. Actually, these greenhouse gases, they are mixed in the atmosphere. They're not just in one place over there. But we have CO2, methane, water, vapor, some greenhouse gas over there. And these greenhouse gases, they are actually very fortunate because they can actually be good for us. These greenhouse gases, like they are represented here in a thin greenhouse gas layer, and by thin, I mean a small concentration. It's not that it's physically thin, it's a smaller concentration of greenhouse gases. It's going to allow light to pass. Light pass almost entirely. A little bit of ultraviolet radiation is filtered, a little bit of the red is scattered, but most light passes through the atmosphere. It hits our planet, part of it's reflected, but part of it is transformed into heat, infrared radiation. So this heat is trying to escape our planet, going away to space. Part of it is not allowed to. Greenhouse gases, they hold this heat and they keep our planet kind of warm, and a little bit of it goes away. If you have a thicker greenhouse gas layer, what will happen is that light will pass in the same way, light reflects in the same way, light will be transformed into heat in the same way. But if we have a thicker, more concentrated greenhouse gas layer, what will happen is that more heat will be trapped inside. So the planet gets warmer, less heat goes away. So the thicker the greenhouse gas layer, warmer the planet will get. The thinner it is, so the smaller the concentration, colder the planet will get. This is fortunate for us actually, because greenhouse gases, they are important to keep the temperature in the planet kind of constant. So this is our planet, sunlight is transformed into heat, heat, a part of it goes away, part is trapped inside. If we take a look in other bodies in our solar system, Mercury, for example, don't have a greenhouse gas layer, and it's very close to the sun. So we expect that it would be very, very, very hot. And it actually, in the sunny side, it is very, 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 very hot. But in the dark side, then it's cold, very, very cold. It can go to minus 170 degrees Celsius. This is much colder than any natural temperature ever registered on Earth. In the sunny place, it can get very warm because now it's very close to the sun. What about our moon? Our moon also don't have atmosphere. So it can get very, very, very cold in the dark side, minus 173 degrees Celsius, and it can get kind of hot in the sunny part, plus 127. All this variation is because there is no greenhouse gas in there. Okay. What about Mars? Mars has some atmosphere, has carbon dioxide in the atmosphere, so it will have greenhouse gas, so the temperature doesn't fluctuate so much. It goes to minus 125 to plus 20. Oh, it can keep the temperature in a decent range. Our planet, which has a very good greenhouse gas, it's in a very good distance from the sun, we have temperatures ranging from minus 89 degrees Celsius in Antarctica, was the coldest temperature ever registered, and plus 58 degrees Celsius, the hottest temperature ever registered naturally on our planet in the Gobi Desert in Mongolia. Okay? And if you take a look on Venus, Venus is a very good example of what happens if you have a very thick greenhouse gas layer. Venus has a very, very, very thick greenhouse gas layer, and the temperature there is quite hot. It varies, it doesn't vary. It is from 465 degrees Celsius in the night side, and it's 465 degrees Celsius in the light side. It doesn't change. It's a very, very hot place, and it's very, very hot because it has a lot of greenhouse gas. So greenhouse gas, it's useful to keep our planet under decent temperatures. Too little of it, the planet would be too cold. Too much of it, the planet would be too hot. Just to show you here the greenhouse gas, how they interact with radiation. The visible radiations over there, we see that water vapor gets a little bit of radiation, but the visible is not blocked practically by any of those five gases: water vapor, carbon dioxide, oxygen, and ozone, methane, and nitrous oxide. Ozone blocks ultraviolet radiation, which is quite good for us because it filters UV, which can cause skin cancer and other problems. So that's very good for us. And that's infrared, which is the heat, and we can see that water vapor is an important greenhouse gas, carbon dioxide is an important greenhouse gas, oxygen not so much, methane and nitrous oxide not as much as carbon dioxide, but it is a greenhouse gas. Okay, water vapor actually is usually not very talked about being a greenhouse gas because we have water vapor on our planet. Water vapor is not going away; it doesn't change practically. You know, we have water vapor and it will be there. We talk a lot about carbon dioxide, methane, nitrous oxide because those are the ones that we are changing with our lifestyle. Just to show you the history with this carbon dioxide, if you take a look on Mauna Loa again, we will see that the carbon dioxide fluctuates every year. Goes up in the winter, goes down in the summer, up in the winter, down in the summer in the northern hemisphere. But what we see recently from 1960 to 2010 is that the carbon dioxide concentration is getting higher and higher and higher. Actually, if we study the ice core that trapped gases from the atmosphere 1,000 years ago, we see that the carbon dioxide concentration fluctuates, but fluctuated very low, around 280 in the last 1,000 years. And only recently, in the 20th century, it started going up and up and up and up and up, all to the levels that we have nowadays. Actually, we are a little bit above there now because we are past 2020 already. So carbon dioxide concentration is getting higher and higher and higher. Okay, so if the carbon dioxide concentration is getting higher, the temperature should be getting higher. And yes, it is getting higher. So this is the temperature after Industrial Revolution. So it's getting hotter and hotter and hotter. And if we see the history, 20,000 years ago, the global temperature was on the average 40.3 degrees Celsius colder. And if we fast forward to today, 2000, no, 1900 and 2000, we have the temperature going high and high and high. So the temperature is getting warmer. And these are the predictions. If we fix everything to be something like that, this is an optimistic scenario, and this is the current trend, what will happen if the temperature keeps going up and up and up. Okay, it's not a good picture. By the way, if you use this QR code here, you can see the entire graph, which is quite funny. Okay, correlation. Yes, there is a correlation. Carbon dioxide is going up, temperature is going up. But correlation not necessarily should imply a causation. Usually, we try to avoid thinking directly that a correlation implies a causation. But if you have a mechanism that one may be causing the other, so maybe one is causing the other. In this case, we know that carbon dioxide and other greenhouse gases, they trap heat. So more carbon dioxide will be trapping more heat, so the temperature would go up. There is a mechanism explaining how carbon dioxide concentration could be causing a temperature increase. Okay? The question is, are we causing global warming with the greenhouse gas emissions that we have nowadays? So there is a correlation, so apparently we probably are. But some people say that actually the carbon dioxide and the temperature, they fluctuate naturally. So don't they fluctuate naturally? Yes, maybe they do. However, we are coming from an ice age, so it's getting hotter. It's, maybe this is happening naturally, but maybe then we are accelerating the process. Maybe we are spiking this up. And what we can see in the history is that nowadays we have carbon dioxide concentration way above any historical and prehistorical records. So carbon dioxide is getting very high, at least compared to the last tens of thousands of years. Okay, so if we take a look back on the carbon cycle over there, then we can take a look on the facts. Okay, facts: we are burning fossil fuel, so we are returning carbon dioxide to the atmosphere that was there 3 billion years ago. So this is a fact. We are burning fossil fuel that have, very fortunately for us, been stored away from the atmosphere 3 to 2 billion years ago. So we are burning them back. That's a fact. Carbon dioxide levels are rising. Okay, in the Ice Age it was 190 parts per million. In the pre-industrial revolution it was 290 parts per million, and now we are getting to 390 parts per million. This is very, 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 very high. Okay, so this is a fact. It is going up. So that's what we have over there. This is what happened naturally, and the carbon dioxide that was put in biomass and fossil fuel, now we might be burning it back and returning it there. So that is what concerns us mostly. Okay, wait. Some people say that we are not causing global warming, we are not causing the greenhouse gas, or all this stuff. Some people don't agree with this. So this brings the idea of a precautionary principle. Precautionary principle says that if two opposing ideas meet, unless you have a strong opinion about one of them, the one that are most harmful should be the one that should be avoided. So to give you an example, smoking. Some people say smoking is bad for you. And some people say, no, my grandfather smoked all his life and he never got sick. So if I tell you that smoking is bad and you stop smoking, if I am wrong and actually smoke is not bad for you, what did you lose? You lose some fags, you lose some smoking, you lose some, no, oh, look, I was smoking. You didn't lose much. But if the opposite happens, if someone tells you, oh, smoke is not bad for you, and you keep smoking, and if they are wrong, what can happen to you? What can happen to you is that you can develop serious health problems that nowadays we know that smoking can cause you. From lung cancer to several cardiac problems, smoking can be very, very bad for you. Although, in the 20th century, there were even advertisements saying most doctors smoke Camels. Smoke is actually not that bad for you. People that believe on them and didn't stop smoking, now, if they are still alive, they have screwed up their bodies. And this is the idea of the precautionary principle. If you're in doubt, follow the idea that is less harmful and avoid the one that's more harmful. So, what about the climate change? Yeah, we are saying that the climate is changing. We are increasing greenhouse gas. We are warming up the planet. First, people said, "Oh, climate change isn't real." Then they start saying, "Oh, climate change is real, but we're not sure that's caused by humans." And now we are in the oops, and very soon we are going to be in the flick. And by flick, I mean something not very so polite. Okay, so precautionary principle tells us that maybe we should pay attention to the greenhouse gas emissions, that it might very likely to be causing global warming before it's too late. Okay, so what are the impacts of this global warming? One of them is weather change. The weather is getting more and more crazy. The weather can get colder, the weather can get warmer, the weather can get drier or wetter, more rains and stuff, and it's unpredictable. There's even a movie, The Day After Tomorrow, that they say that the global warming caused a change in the North Atlantic current, and that change in North Atlantic current actually stopped the current, which made the northern hemisphere all to cool down very drastically. It's an interesting movie, it's fun. Not very likely to happen, but okay, it is one thing that can happen. Weather can get crazy. Okay? Another impact that we can have stronger storm, more and more hurricanes. Hurricanes are powered by hot water. And the hotter the water is stronger the hurricanes become. If you are not remembering, Katrina was a massive hurricane that hit the United States, caused billions of dollars in prejudice, kills lots of people, 1,200, but it can kill many more people in poor countries in the Caribbean. Hurricanes can be very, very bad, and they are becoming more frequent and stronger every year because the temperature of the oceans are getting hotter. Okay? Another impact is the melting of the ice caps. So in yellow is the ice cap around 1979 and 2000. In green is the ice cap, the minimum ice in 2005, and the white over there with the red border is the minimum ice in 2007. So the minimum ice in the North Pole is getting smaller and smaller and smaller. So the ice is melting. If you take a look in Antarctica, it's also melting. If you take a look on glaciers, they are melting. That's a 20 years gap, and the glaciers have drastically changed. That's the same place. So ice caps are melting, and that can cause a few problems. One of them is loss of habitats. Animals like the polar bears in the North Pole, penguins in the South Pole, or seals all over the place, North and South Pole, they depend on the ice to live. If they don't have the ice, they starve, like this polar bear here. This polar bear is not being able to hunt to get seals because it has no ice. It has to swim a lot, lose lots of energy. This polar bear is very likely to go into die because it's not feeding, and it's not feeding because of habitat loss. Okay. Another problem can be competitive exclusion. This is the red fox and the Arctic fox. The Arctic fox distribution is that orange over there, in the very, very north of the continents, and the red fox distributed all over the world, but mainly in the north hemisphere, almost very north. And what's happening is that if the planet becoming warmer and warmer and warmer, these foxes are capable of moving and occupying, invading the space of the Arctic fox. So if the temperature keeps warming, 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 what will happen is that the Arctic fox is probably going to get extincted by competitive exclusion with the red fox. Okay? And another problem is that with the melting of the ice caps, the sea levels are rising. This is a projection of what will happen in Manhattan in 30 to 50 years from now if the temperature keeps increasing and the ice caps keeps melting in the rate that they are melting nowadays. So this is a real estate problem, okay? Because lots of lands where we live are going to become underwater. So that's a big problem, okay? Corals also are suffering. Increase in temperature causes coral bleaching. Coral bleaching is a coral whitening because they lose the zooxanthellae. Zooxanthellae are tiny little organs that do photosynthesis and live inside of corals. But if the temperature goes above 29 degrees Celsius, the corals expel the zooxanthellae and then they start starving because they don't have photosynthesis happening inside of them. So, too hot, it can be a problem. The second problem is that increasing carbon dioxide in the atmosphere increases carbonic acid into the ocean, which reduces the pH. With a smaller pH, calcium carbonate is not so easily fixated and is dissolved. So, corals and other calcium carbonated body animals are losing their body. So, ultimately, corals and other animals are struggling because of the increase of greenhouse gas and of the increasing of the temperature. If you want to know more about this, I suggest you watch this movie, Chasing Coral. It's touching, beautiful, so you can see that maybe you can do something about that. If not, just learn how to dive so you can have the experience on visiting corals while they still exist. Okay? So what can we do about all this stuff? So one thing that we can do is to try to reduce greenhouse gases emission. So we can use less cars, we can ride our bicycles, we can walk to school, we can try to go for cleaner electrical production like hydroelectrical instead of thermoelectrical. We can go for electrical cars and so on. There are many things that you can do. But in Brazil, fortunately, we can choose fuel. We can choose between alcohol and gasoline. And if you study chemistry, you can ask yourself, which one releases more carbon dioxide per kilometer that has been run? If you learn chemistry, you see that you can actually calculate how much energy is in each of the bonds. So carbon hydrogen has 413 kilojoules per mole, carbon has 346, and if you get the formula of alcohol, and if you get the formula of the typical gasoline, which has an octanage with 8 carbon over there, we see that kilometer by kilometer, alcohol and gasoline emits the same amount of carbon dioxide. Oh, so what? Which one is best then? If they emit the same amount of carbon dioxide, so both are bad. But actually, if we take a look on how alcohol and gasoline are produced, alcohol is produced with a recent carbon cycle. So recently, 1-2 years ago, a plant did photosynthesis, put carbon dioxide into its body, and then we fermented this to be able to make alcohol, and then we burn alcohol to move our cars. So alcohol has everything to do with a recent carbon dioxide. Whatever you're burning now was in the atmosphere 2 years ago. And then what you're going to be burning 1 year from now is going to be in the atmosphere before. So it's a very recent carbon cycle. So it's a recent cycle, and as a result, it makes the carbon dioxide to go up and down, up and down, up and down, because the plants get from the atmosphere, they put back into the atmosphere. They take from the atmosphere, they put back in the atmosphere. So it's a recent cycle. It's not so drastic. It's not increasing much the carbon dioxide in the atmosphere. Gasoline, on the other hand, emits carbon dioxide that was there 3 billion years ago. So as a result, you have an old carbon cycle, restoring carbon dioxide to the very, 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 very ancient levels, which were very high. So if you take a look on the historic carbon dioxide for a very, very long time, what is happening is this. And this can be very problematic because all those problems I told you about the rising temperature, they are over here. And if we keep putting it high, 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 if we get to levels like this, life as we know it is going to be completely changed. So we are not going to be around if we let carbon dioxide get this high. So if you want to know more about this, there is this very cool video from Kurzgesagt. Actually, they have a series of videos about global warming and greenhouse gas, but this one is discussing, is it too late to stop climate change? Well, it's complicated. Take a look at this video. I strongly advise. It's a very good one. Another video that I suggest you to watch is this movie here, An Inconvenient Truth by Al Gore, and an inconvenient sequel, Truth to Power. Both of them can be found in this link. They are very, very good movie. I would say that's almost mandatory for you to watch them. I hope you had fun. I see you in another class.